Right, welcome to the last session of computer applications module. So this is the session number 10. And what we have done so far, we have learned the basics of Python programming. And also we covered the main modules under the topic, right? So today will be our last session. And after the last session, we'll have 1 week break and then we'll have the exam. So exam will be same as the same format we have used for Kahoot, but it'll be proctored in Zoom. So I will give you like offline quiz for you to practice. So I'll cover the material that we want to do, and then we'll have a mock exam in the sense that we have a quiz session, but without any proctoring. But in the real exam, we'll have Zoom proctoring, which means you have to switch on your video so that it makes sure that you work on your own. Right. So having said that, my plan for today is we'll cover the visualization part. And then once we finish the visualization part, we'll have a small session on all the topics that we have covered in the module. And then we'll have final quiz. Okay, so having said that, let's start. Let me share the... Okay, so I hope you can see my screen. And what we covered last time, if I just quickly go back. So we covered simple visualizations in Python. Again, very important topic. I hope the material that we have covered is very useful for other subject as well. Often that you want to represent data visually. And in Python, there are many visualization libraries are available. But Matplotlib is quite common, and which is actually the basic plotting form we have used even in MATLAB as well. So you can see the same name we have used there as well. When we want to create a visualization, basically the important modules that we have to use is Matplotlib PyPlot. And then we renamed this as PLT in short. And then also we use NumPy, especially for generating vectors and matrices, which we have covered in one of the previous sessions. So if you look at our first example, we will have set of a vector which contains a set of numbers, and simply we have to use plots, subplots to generate figure and axis, which I will discuss today with the subplots in more details. And simply the command that we have used is the plotting command, the plot y. And when you say show, you can see we have the simple plot. Right. And generally, when you want to create a plot, we have to generate both x and y. And I told you, like, you can use simple list, no issue. But then we also recommend you use NumPy and the array, which will be more efficient is when you're handling large data sets. So in this case, we have defined two vectors, x and y, and then we created a figure and axis label, and the command that we have to use is plot x comma y. Now that is a simple line plot we are getting. Then the next part that we have discussed is generating a sine curve, which we have used several functions. First one, in vector x, we use a range method that we have discussed early, where we define start, stop, and step, the three values. So starting value is minus pi. So when I say minus pi, minus 1 into pi value, which is coming from numpy, comma to pi. So that means we are generating values between minus 5 to plus 5 with the step of 0.01. So this is the step. And then we use sine of x to generate y. So when you plot, you can see the sine curve like this. Then next, what we discussed is how we can use the customizing these curves. So when you want to customizing these curves, right, you can always use what we call the formatting string. That means after plot x comma y, then the formatting string will tell you like the color of the plot, the marker, as well as the line type. So I told you, like, if you want to know more details, you can just type help plt.plot, which will list the formatting string. So formatting string, we have three parts. We have marker, we have a line type, and the color, right? And then the markers listed like this. You can use dot, comma, O, which is circle marker, which I have used, and V for triangle down marker. So there are many markers which you can choose from. And then there are line types. We have solid line. If you put a single dash, if you put double dashes, you have a dash lines, dash and dot, we have a dash and dot line, and colon, which represent dotted line styles. Similarly, you can use basic colors. Actually, you can use any other color as well, but the basic colors are represented here. B for blue, G for green, R for red, and C for cyan, right? So this is the place we have stopped last time. So for example, in this one, you will notice we have green with we have triangle down, and then we have a dotted line. So you can just change. For example, let me run. Okay. So, and this is what we are getting. And then you can change. For example, if you put, let's say, dash and dot, which represent dash and dot line type. You can see dash and dot line type. And if you put O, which represents circle marker, right? And you will notice the marker has changed to, circle. And then G for color, let me put R. So this will change the color as well. And this is where we have finished last time, right? Okay. Now, having said that, let's continue our today's session. So in today's session, the next thing that I would like to discuss is how you can actually provide the labels. So this is not, complete one. So let's put up some labels. So let me copy paste this one to a new code window. I'm going to get a new code window. So today we are going to talk about session number 10. And when we run, you will notice that, okay, this is the graph, right? And then let's put up a title. So when you put up the title, again, remember, you can use, like, after plotting axis labels, right? So we can actually change the values. So first of all, you can use in this format. Right, now after this subplot command, we can actually provide what labels we can use. So for example, if you want to title, after plotting, we can say, okay, ax dot set title. So when you say set title, you can, as a string, you can put up the name for this. So let me say this is y equals sine of x. And when you run this, you can notice that it has changed the title of the plot, right? Similarly, you can try providing x label, set x label. That means x-axis label. Let me say this is in angle, in radians. Then we have y label. Y label, let me use this as sine of x. Right, now we have provided 3 more commands. So let's run this and observe the outcome. So you can notice here we will have the x label, angle in radians, and this sine x, and then this is the title. Okay, if you finish up to this point, please raise your hands. Okay, so the next part, if you want like a grid, like sometimes it's always, help to have a grid in this. So simply you can use ax.grid, and this will command will set up a grid which you can guide the values, so easier for you to read the values. So the command is ax.grid. And also if you want to put up a legend, like in this particular case, of course, we have only one graph, but especially when you have multiple graph, so we can say axis legend, and then you provide the labels as a list. So in this particular case, we have only one value. So when you put up this value, right, you can see it as a legend. Right. One last thing is about the options. So sometimes actually you can change the fonts, the font size and everything, but you can read it about just checking the help function. Let me try this axis. Okay, so here is a place where we normally put the title. So now we have had grid and legend, right? Let me just to show you like all these places you can have options. Let me check and see whether this help function. So I'm going to try to see whether I can get the help. Right. So in this particular case, I will just type help. And within this, I will put axis set title. So you can see here, when I say AX set title, I'm going to, get the help on how to set up the title. And you can see here, it says set title and the label, font dictionary none, location none, pad none, and so on. And you can read this. Label means text to use for the title, and that's what we did. We put the set title as y equals sine of x. Okay, this is the place I want to handle, your attention. So font dictionary means as a dictionary, you can set up different values. For example, you can change the font size, font weight, even you can change the color as well, right? So let me just show you like how to set the font size. Let's say you want to have a little bit more increased font size. So let's use this. So you say font size and whatever the parameter value, actually you can put some basic value here, let's say 20. So 20 will indicate that 20 pixels. So here, for example, so after title, I'm going to put a comma. As a second argument, I am going to have a dictionary, and then we have a set of value, font size. We have learned about the dictionary earlier, saying that you have always key and value pairs. So we will say, okay, font size should be 20. Actually, you can change the value and see. So if I run this code now, you will notice that you have an increased size of the title. You can try changing the color. You can try changing the font as well, which I'm not going to discuss. But of course, I think you should be able to figure this out. Okay. Now, generating multiple plots involve a couple of things. So let's start looking at generating multiple plots, right? So when you draw multiple plots, we can do, several ways. One is you can put everything in a single plot, or you can have several plots in a same figure. So I'm going to start with plotting multiple data sets on a single plot first. So let me start a new coding window. So let me open up, sorry. So in this one, what I'm going to do, I'm going to plot multiple data sets on a 2D plot, right? Of course, if the time permits, I will look at 3D plots as well. So the first one is we have to generate some X and several Y values. So if you remember what I did earlier, I generated set of values between -pi to +pi. So this time I'm going to generate set of values from -2pi to 2pi. So let me use X equal np dot range, and you remember the values now, start, stop, and step. So starting value is -2 into pi, np dot pi will generate the value for -2pi. To +2pi, I will say np dot pi, and the step of 0.01. Right. Now this is my X value, because what we need is a radian value. I told you like in radian. So let me put y1. So in y1, I will say np dot sine of x. That is the first curve. So y2, I will generate np dot sine of x minus np dot pi by 2. So this is the second one. Let me put I'm of course going to have like three sine curves. NP dot sine of x minus NP dot pi, right? So there are two methods actually we can talk about. So the method one, so I will say this is method one. The first method is we can have everything in a single plot command like this. So I will first create figure and axis using subplots command, right? And then I will say, okay, plot. Okay, here, earlier we use x comma y, right? So now I'm going to list everything like this, x comma y, sorry, x comma y1, comma x comma y2, x comma y3. Simple as that, right? And then let's use figure dot show, right? So let me run this. Now, if you run, you will see now three curves, right? We have a blue line, orange line, and a green line, three curves. So let's label them to identify which one is which. So I will have legend, right? And I told you like you have to have a list. So first one is sine of x. The second one is sine of x minus pi by 2. Third, we have sine x minus pi. So if I run this, right? So you can see the first blue color will be the sine of x. The orange color is sine x minus pi by 2. The green one is sine x minus pi. Right. Okay. Now it's your turn. Now that we are familiar with using subplot command, multiple plots. So let me discuss the second method. It's nothing new, but you can separately have three plot commands. So I'm going to just do only the second part of this. So the method two is same three functions. I'm going to create another figure and axis using subplots command, right? And then I will say, okay, axis and plot. We can say x comma y1. That means you are going to have separate plot commands. So let me put the legend as well. Sorry. Yeah. We have sine of x minus pi by 2 and x minus pi. So you should be getting the similar output. Now, if you ask me like why we have like two methods and what is the importance of this? Now, sometimes if you want to make the change of individual the plots, then this might not, the first method might not be the best one. Now, for example, let me change the right now in this particular case. Since we have three separate plot command, you can change. Now, for example, let's say I want to have like more width for the first curve, so that I can actually change by putting line width and then putting the value. So in this particular case, you can check. You can, of course, check on the values. So let me put line width here. So when you run this, for example, you can see now our first sine curve, we have a line with, we have increased it to 3 pixels. So it's highlighted. So in case if you want to change, the plots, right? So you can use this, the second method. So let's discuss subplots. We have x and y1, y2, and y3. So now when you are creating figure and axis, now this time I'm going to create 3 axes. So what I'm going to do is I'm going to have 3 plots. If you look at it as a grid, let's say you have a single row and you have 3 plots. So in that form, in that particular case, I have to create like this. So I have to first say plt.subplots. Now, earlier we have not defined anything because we didn't specify it. Now I'm going to say 1, 3. So when I say 1, 3, what it means, we have a single row and we have 3 columns, right? So which means you will notice that we have a figure and now we have to create 3 axes. Let's say we have AX1, AX2, and AX3, right? Now let's go at one time. Let me have the first one. We have AX1. We will say plot x comma y1. Let me run this. So it should be plot. Right? Now you can see it has 3, right? So it has 3, but we have draw only for 1 because we have defined it here. So how the plot should look like. We have 1 and then that means single row and has 3 columns, right? So that's the first one. So let me put the other values as well. X2 dot plot x comma y2. So let me run this. So now we have put up the second one as well. So let's have the third one, x3 dot plot x comma y3. Yes, we have 3 plots like this, right? There are some overlappings here if you want to avoid we can also use this one. We can say, okay, figure type layout, which will, adjust so that you can no overlappings you will see here. And finally, we can say figure dot show, right? Which will generate a subplots. Okay, so let me increase the size of the font so that it's visible for you. Oh, now let's look at some general, charts. The first one that I would like to discuss is how you may create a bar chart, right? So the command is bar. So for example, to draw a bar chart, right? So we can define what X and Y value should be. And then we can simply say, instead of plot, we say bar, right? So let me put a simple one. Let me have a X values. Let me put 0, 1, 2, 3, and 4. And then Y as, let's say we have 10, 20, 30, 50, and 60. Simple and X and Y. So you create figure and axis labels using subplots command, right? And then the command is ax.bar, sorry, bar instead of plot. So X comma Y, that's all. And finally, we have say figure.show. So which will do a bar chart. Right? So we have seen in use of bar charts. So instead of plot, we have to use bar method, and then you provide X and relevant X and Y values. So let's start. Right now, in this particular example, we have a very simple bar chart. So in this bar chart, we have defined both X and Y, and then we say Ax bar, X comma Y to get the bar chart of this. Right. The next thing that I would like to discuss about this, we can have several values. In this particular case, we can have multiple values, and then we discuss how we put them. Right now, so let's say we have, what we call group bar chart when you have more than one. So let's discuss how we can handle that. So when you have a group bar chart, or when you want to have a set of bar charts, we have to do slides adjustment, and I just would like to discuss the details. Now, in this particular case, let's say we have same one X values. So I'm going to take this, copy paste X and Y. Okay. So let me take everything, right? But I will change a bit on this one because we already know that you can generate automatically this one. This is a pattern. So I can use np.a range 5 will generate 0 to 4, which is what we had earlier. And then let's define another label. This time, let me put at C, and we have 20, 30, let's say 35, 45, and 50. Right? And next command will be the same. Right. Now, last two, let me discuss. There are a few things that we need to discuss. The first one is we can say ax dot bar xy. The second one we can say over x comma c. Again, no change. So when you run like this, you can observe what will happen, right? Okay, maybe I have to type both commands. So let me import from the beginning. So I have to write import matplotlib.pyplot as plt and import numpy as np. Right, now let me run this. So now you can see how the bars are stacked. Now, reason for this is basically when you plot, it will plot individually as 2 layers. So what needs, we have to adjust, first of all, the width of this. For example, what we want to have. So for example, in this particular case, we have to decide width of this, right? So width of this. So basically in that particular case, what we should do is we are going to make a decision on how much width we are going to use. So width of the bars. The right now, we can decide on, 50% or 40% of the original. Right now, it's the same. So one adjustment I'm going to do is I will put another argument here, and I will say, okay, width of this should be, let's say, 0.4. You can actually change and see what will happen. So for both, we will first put the width, right? And now you can see the bars are adjusted, the width is there, but it's still both the bars are not visible. Now, this could be done by just adjusting the x value slightly with some offset, introducing some offset value. So this offset is basically depend on how much we want to have, right? So that basically we have to decide on how much you want to have the offset. So in this particular case, I can say x is 0. So that means it's here, right, at this particular place. But let's make it a bit of offset. So that means I will plus some offset value. So the second one I'm going to bit adjust. I will put plus, and then since the width is 0.4, I will offset to 0.4. Let's see what will happen, right? So the first one is x, and the second one I slightly offset by just typing 0.4, and let me run this. So now you can see it's a bit of offset. Now you see, if you want to center out these labels, the best way would be you offset both by adjusting this width. Actually, this is the width we have decided as 0.4. So the best way to do this is I actually distribute these 0.4. So that means I will subtract 0.2 here, right? And then add 0.2 here. So that now it will nicely balance. So now you can see it's nicely balanced and it's in the middle, right? So this is one thing you have to make a note on when you're actually creating bar charts. So offset, and then, the width needs to be adjusted depending on how many bars you have to have. So since we have 2 bars here, it should be less than 0.5. When we have 4, then you can have 0.25 and so on. So this is how you might, decide on when you have group bar charts. Okay. Now, having said that, I'm going to look at the scatter plot. Right. Now, what we need here is, I'm going to first work on some random numbers. So this time, let me define X as np.random. I hope you remember creating rand and n, which create some random numbers. This n is, let's say we need 20 points. So we will get, 20 points, 20 random numbers. Y is also, we will set, right, 20 random numbers. And then let's create figure and axis. In this case, we have to say subplots, right? The command is scatter and x comma y. And then simply we can say show. Now, scatter plot means simply some set of random labels. Now we said 20. So for example, I can put, let's say 100. You can notice the distribution, 100 points. And every time you run it, you see you will get a different set of values. This is because it's random. Every time you will get different set of values. If you want to fix it, which is the major case in most of the time, so you better define something called seed. So seed value, which defines any integer value you can put. Let's put 1. If you say 1, for example, every time, if the seed is 1, every time you will get same set of random numbers. Although it's random, we normally call it a pseudo random, right? So you see the creating random number. So let's put 20 so that we have a very simple scatter plot. Okay, that's what we need to discuss. Let me define, in this particular case, we have a single set of labels. Let me define 2 groups within this. So I'm going to copy paste the same. And then I will take a new coding window. I'm going to slightly update this. I'm going to give some labels, right? See whether you can understand this one. So I'll get a new one. So I hope you remember putting zeros. Remember np.zeros? We have 20 points here, right? So when I say np zeros 10, we'll get, 10 zeros. And if you put ones, we'll get 10 ones. So I'm going to have 10 zeros and 10 ones. So simply I'm going to stack, right? Saying that np.h stack. Then I will say np.zeros. I will put 10, right? Comma np.ones, again 10. So what happens, what I'm going to do here, I will create a 10 zeros and 10 ones. So I will take this as C, which is the next one. And I'm going to assume that this as a kind of class labels. I have 2 different classes. So what I could do now is, depending on the class, I can show these points in different colors. So I put colors I will define as from C, the set. In this particular case, what it means basically, we are going to have an array like of colors or option, mark colors, so possibly we can put anything that you can do there. So we basically put them into another, the class label. So the first 10 is in one color, the second set should be in second color. So when I run this, now you should observe that, okay, 10 points in a one color, another 10 in another color. Hope you understand this. Right. So try this, and if to create a pie chart, let me put pie chart. So usually in pie charts, we can have set of values. And let me define a very simple one using simply a list of numbers. Usually the numbers we will have percentage values, but if the values are not added to 100, in this particular case, it's added to 100, but if it is not added to 100, usually it will calculate the values and adjust accordingly. Now, you can have figure and axis defined like in previously. And then you can simply use pie chart, and simply you can put X, which will draw a pie chart. Right. So if I run this, now you can observe that we will have a very simple pie chart is, put it here. But then now, if you want to improve by, let's say, with some labels, then of course you have to define another list which contains label. Let's say the 4 parts I will label as simply A, B, and C and D, right? So I can update here by saying that, okay, this is labels, and then I will put L. So if you run this, so this time you can notice the labels are around and it's clear. But of course, at the same time, let's say if you want to improve the graph by putting percentage values, then one thing that you can actually add it here. So after the labels, you can have auto percentage. And then you have to define the format, right? So if you need, let's say, 1 decimal place, this is how you will put, right? In this particular case, all the percentage values are put in as a 1 decimal place. So this point should be F to say it's float. Okay. So now you can see we have an improved pie chart with all the percentage values within the graph. Okay then. So with that, we can actually finish our discussion of the visualization using matplotlib library. And with that, we completed our most of the topics that we were planned for basic computer applications module. And throughout this, what we discuss is the basic Python programming. And I have introduced a couple of modules which is useful for you to start, exploring. The 2 main things that we have discussed is numerical Python library as well as matplotlib library, right? With this basis, I'm assuming that you can comfortably start coding in Python, especially in your, in other subjects where you need some computational, programming or solving problems, especially in other subjects. Right. So with that, we will conclude, finish this, and then next half an hour, we will have our last quiz. And once we finish that, we can discuss how we proceed with our examination.